Hello again. Okay, I'm getting kind of situated here and trying to figure out a video setup that would work. So this is take 2 of Quadratics Day 2. I'm hoping that you watched the video from Quadratics Day 1 and completed the homework from Quadratics Day 1, and that'll be turned in the next time I see you. So today's lesson is further discussion on parabolas, and specifically the same vocabulary we talked about yesterday or the previous lesson. We'll talk about those again. So axis of symmetry, vertex, minimum, maximum, roots, zeros, and the x-intercept, or I should say x-intercepts, because there could be more than one. Those will be what we want to make sure we understand from looking at our graphs and our tables. First thing I'd like you to do is try the warm-up. So now would be a good time to pause the video for you to take that time to try the warm-up. So here's how you do the warm-up. It asks you to do this in your calculator. So take a look at my parabola, which is a quadratic function. So I'm going to go into y equals, this is from the previous lesson, I will clear it out, x squared minus 2x plus 1. I always like to look at the graph first, just to have an idea of the shape of it. Also to make sure that I typed everything in correctly. You should have a parabola because it's a squared function, and anytime you have a function where it has x squared, that's the name, a quadratic function, and that'll produce a parabola. So I'm taking a look at this one, and now I'm gonna graph it, but in order to do so, I will find the points from the table. Second, graph. And again, last lesson, what we did is we found that window that kind of had the top number and the bottom number the same. So what you work your way towards the center, that'll help us identify the vertex. In addition, in the warm-up, I asked you to actually graph it, label the table from -2 to 4. So I'm just going to copy down the values from my, where did I mess up? 4101. 49. So those are the values from my table. The vertex will be in the center, right there. So the vertex is the point 1, 0. And I want you to make sure to put a star next to it in the table of values to show the vertex. Anytime you give me a table, when I ask you to graph a quadratic, I would love it if you put the vertex in the middle, gave some points to the left of the vertex and to the right of the vertex, just to have a few to plot. If I were to plot this, at least I'd have the ones that would fit on the graph paper. So that's just a follow up from yesterday. So the first example we have in our notes today, I'm asking you to fill in this table. So I gave you the graph, and I already plotted 2, -1. I also plotted 4, 3, and I plotted -1, 8. What I have done for you is had you recognize that the vertex should go in the middle of the table. So let's label that first, vertex. And what we've talked about is that there's symmetry to this parabola. So on the other side, this is the point 0, up 3. Notice they're both going to be up at 3 and 2 steps away from the vertex. I see a point here that's over 1, up 0. And I see a point here that is obvious. It's friendly points at, it's not over 1, up 0, that's over 4, up 0. Smarties to whoever saw that. This is the point 1, 0. So let's label some of these in our table. We'll go up by 1 and fill in the rest of the information. Oh, and 5, we know it's going to match the other side, so that'll be at 8. When x is 4, y is 3. When x is, oh my goodness, double Smarties. When x is 3, y is 0. When x is 1, y is 0. When x is 0, y is 3. So now I think I filled the table in correctly. Label the vertex on the graph. Vertex. And on the table as a minimum or a maximum. So there's my vertex, and I knew that was going to be by itself These have matches, these have matches, these have matches because of the symmetry of a parabola. So when I look at this vertex, I can see that this in fact is the lowest point of the parabola. So I'll label it as a minimum. If the parabola was a frown, then the vertex would be a maximum. But in this case, it's a smile. So circle the x-intercepts on the graph. So where they cross the x-axis, they're right there. And what is the value of f of x at both x-intercepts? So whenever I ask you about the value of f of x, I'm talking about the y value. So what is the y value where it crosses the x-axis? The y value is 0. So I've circled the x-intercepts, I answered that question, and I'm asking for, write the equation for the line of symmetry. And again, the axis of symmetry is always going to be an equation, and for us, all of our parabolas are going to be smiles or frowns, so it's definitely going to be an x equals the value of the x coordinate of the vertex, so the line, where that's the line of symmetry, will be x equals 2. So I'm going to take day 2 and flip it over, or you could turn yours over in your notebook, and go to example 2. So I have a second graph, and this one is so sad, it's a frown, or concave down. Let's fill in the table. So my table has the vertex right in the middle, and it's the point -2, 4. I know there's going to be symmetry, so at -3, 3, the one to the right of it, which is -1, that will also be at 3. I see a couple of points that cross the x-axis, so at 0, the y value is 0, and on the other side of that, -4 is at 0, and at 1 states it's at -5, so if I go 1 in the other direction, -5 will also be at -5. Your x column in your table best goes up when it goes up by 1, for us for right now, and this one is where you should look to see if they have the matches, where you put the vertex right in the middle. So we filled the table in, label the vertex on the graph and on the table, and because it's our highest point, it's considered a maximum. Circle the x-intercepts on the graph and on the table. So again, where you look for them on the graph, that's where it crosses the x-axis. The y value is 0. So I can say f of x equals 0 or y equals 0. In other words, we're looking in the second column as to where the y is 0. It happens here and it happens here. So this is called an x-intercept, and this one's called an x-intercept. Because the parabola crosses the x-intercept twice, we have 2 x-intercepts. Write the equation for the line of symmetry. It's at x equals -2. Third example, let's see. Graph the parabola given the information in the table. Complete the graph by plotting 3 additional points of the quadratic function. They tell us the vertex is at -1, 4. So that right away tells me there's symmetry around that point. So we know this point should match as long as all of these are going up by 1, which they are. That'll have a 3 as the y coordinate. This will have a 0, and that'll have a -5 because of the symmetry. So how we found those points is a parabola is symmetric. One side matches the other. So let's plot them. I like to plot the parabola's vertex first. And what's interesting about this one is that I'm having you plot it upside down. And then 2 is at -5. So remember, my parabolas should curve. You should do your best to not have them have a point there, like a V, because that's an absolute value function. So a parabola will always be curved like a U. This one is a frown. What are the coordinates of the x-intercepts, and circle them on the table? X-intercepts are when y is 0. So we look for the y to be 0, and we look for the y to be 0. I should probably label since I already circled this. That's a vertex. This is an x-intercept. And running off the paper, this is the x-intercept. Really looking for where it crosses the x-axis. So what are the coordinates? Well, one of them is at -3, 0, and the other one is at 1, 0. Okay, what are the coordinates of the y-intercept? That's where it crosses the y-axis. So the coordinate of that point is at 0, 3. That's just so we're aware when x is 0. Okay, so when I look for the y-intercept, I look for when x is 0. When I look for the x-intercepts, I look for when y is 0. It's kind of a backwards thing there. So what are the coordinates of the vertex? Well, we've already established that because they actually told us in the beginning. And is that particular point a min or a max? And it's actually a maximum because that would be the highest point out of all of the points of the parabola. Man, this is quick. All right. Example 4. The symmetry properties of quadratic functions to sketch the graph of the function below. So we know it is symmetric. I have to tell you where the vertex is. So we're saying that 1, -4 is the vertex. So I know that's where my line of symmetry will go through. So I have to, if I'm one step away from that line of symmetry on this side, I go one step on the other side. There would be a point at that parabola. Go up to this one. That's 2 steps away from the axis of symmetry. So go, did I count that right? 2 steps to the left on the other side of that line. Okay, so this is my line of axis of symmetry. So now that would be 3 steps away. So we're gonna go 3 steps away. This is what my parabola would look like, making sure that it's symmetric and curved. Write a table of values that include the vertex and the zeros. New word, zeros just means x-intercepts. Fancy word. So I want to make sure when I label this table that I place the vertex in the middle, so then I can place the symmetric points on either side. 2, -3, 3, 0, 4, 5, 0, -3, -1, 0, and -2, 5. I'm going to verify that I did that correctly. This is my vertex, and these do match, and we went up one step at a time. Great, I think that one's good. So now is where you should pause the video again and try these 4 practice problems. And I'm back. Okay, so here's how we do these 4 practice problems. So we're going to graph here. If you would like to, it's not a bad idea to use your calculator. You can find this information of any parabola from the tables by placing the equation into y equals, again, make sure that's not a negative, that's a -6x. That's your negative button, that's your minus. Graph it so you get an idea of what it looks like, so we know what we're dealing with. It is a U, it's a smile, this is a happy parabola. So we're going to identify the zeros, the x-intercept, the y-intercept, and the axis of symmetry. My favorite part to do first, my calculator's correct, I need to look at the table. So I'm going to go to the table and find that vertex. Try to get my table so that it fits in there, so that the top number and the bottom number are matched, and then I could find the guy that's all by itself, which is 3, -1. Put him in the middle. Okay, so now 3, -1 goes there, 4, 0, 5, 3, 6, 8, 2, 0, 1, 3, and 0, 8. Just to check. Okay, that one's not going to fit on the grid. So that's plenty. There is 3, -1. That's my vertex. And I have 1. Wait, let's do 2, 0, 1, 3, 0, 8. And those symmetry properties. Here's my curved parabola as best I can. Zeros are where it crosses the x-axis. So I actually want to identify, I know that the y-coordinates are going to be 0. I'm sorry. Yes, the y-coordinates are going to be 0. So I want to identify what the x-coordinates are when the y value is 0. So I'm looking at 2 and at 4. If you were to label it, and you already did this, at 2, 0 and 4, 0, I'm fine with that right now. The y-intercept is where it crosses the y-axis, so that's at 8, and that axis of symmetry would be where it goes through the vertex of its x-coordinate, so it's x equals 3. Next one. Place it in my calculator. I guess I didn't need to clear that out. You can type over x squared minus 2x minus 3. Look at it, just so we, look at it, see what we're dealing with. There's my parabola. Let's plot it. So the vertex is not going to be too far off from there. Get that centered. Vertex is at 1, negative 4. Copy down the rest of the table. Okay, so here is my vertex. That's the guy in the middle by itself. And go ahead and plot it. 0, it's a negative 3. Negative 1, it's at 0. And negative 2 is at 5. Does the next one fit? Nope, so we're good. Match it on the other side. There's my parabola, nice and curved. Let's smile again. Crosses the x-axis at negative 1 and at 3. And remember, the squiggle brackets are for when you have a list. When you're identifying a point, that's when you use the parentheses. The y-intercept crosses at negative 3. And the x-axis of symmetry will be x equals whatever the x-coordinate is of the vertex. 2 to go. Ooh, this one's a fun one. So go to y equals, clear it out. Be careful of how you plug this in. This right here, you actually have to use the negative button. And in the parentheses, you need to write x minus 3. And you can either use the squared or you can do caret 2. I'm going to go squared. So make sure that first part is a negative and then a minus. So if you get an error, this is where you'll need to come back and make sure you actually put a negative and a minus. Negative, minus. Let's look at the graph to see what we're dealing with. Oh, poor parabola. He's sad. So let's look at the table. Go down until I find the vertex. I know I hit the vertex. When I can figure out the middle, the guy that's by himself. Well, that's fancy with the hole punching here, huh? So the vertex is at 3, 0. And the rest of these, maybe I can't fit it in there. 2, negative 1, 1, negative 4, 0, negative 9, 4, negative 1, 5, negative 4, and 6, negative 9. Okay, so now that I have those, I'm going to plot them. Will look like that. My zeros are where it crosses the x-axis. This only crosses once, so there is only 1 0. When it crosses the x-axis once, there's only 1 0. There's only one x-intercept. It does cross the y-axis at negative 8, so the y-intercept is, negative 9, so the y-intercept is negative 9, and the axis of symmetry is when x equals 3. That equation. Okay, last one. I have y equals parentheses, x plus 5, close the parentheses, square it, plus 1. Look what we're dealing with. Okay, so the axis of symmetry will be over here. The vertex is going to be in the negatives. So when I look at the table, I'm going to know I have to go up to find the axis of symmetry, and I found it as there's matches. So plugging in the middle is negative 5, 1. Negative 4, 2, negative 3, 5, negative 2, 10. Okay, so let's plot those. Notice I'm plotting everything that fits on the grid. So my vertex we found to be negative 5, 1. This one, x equals, when does it cross the x-axis? Uh-oh, there are no intercepts for the x-axis. There are no zeros because it never touches the x-axis. The y-intercept, it will eventually touch it. But since I can't see it on my grid, I'm actually going to have to use the calculator for help. Remember, the y-intercept is when the x value is 0. So let's look through our table for when x is 0. So when x is 0, according to my table, it's at 26. So the y-intercept is 26. And then the x of symmetry is x equals -5. Okay, so we've gone through quadratic stage 2. Now you should move on to this, where it's the spiral review. And you have a couple, this is not, this is a choice question, and this is multiple choice. And some more graphs for you to figure out if you know the vocabulary. Have fun!